Intro. Hello everyone. Welcome back to our channel. Today, we're diving deep into something that's increasingly vital for businesses and tech enthusiasts alike: building a production-ready AI workflow. As artificial intelligence continues to mature and adapt, the need for efficient, scalable systems has never been more critical. We'll explore how to integrate automated data pipelines with model deployment, creating a seamless workflow that ensures your AI projects are not only effective but also sustainable. So, let's get started. The importance of a production-ready AI workflow. First, let's talk about why a production-ready AI workflow is essential. When we refer to production-ready, we mean a system that's reliable, efficient, and scalable enough to handle real-world applications. Many projects get stuck in the development phase due to inadequate infrastructure or poorly designed workflows. A solid production-ready AI workflow ensures that your models can be deployed and maintained effectively over time. Having a well-defined workflow helps you manage the entire lifecycle of your AI projects, from data collection and pre-processing to model training, evaluation, and deployment. It also simplifies monitoring and updating models as you gather new data or as business needs change. By integrating automated data pipelines with model deployment, you can create a system that's not only functional but also adaptive to changes in your environment. Understanding data pipelines. Now, let's break down the first part of our workflow: automated data pipelines. A data pipeline is a series of processes that move data from one system to another while transforming it along the way. In the context of AI, this often involves collecting raw data, cleaning it, transforming it into a usable format, and then loading it into a database or directly into your model training pipeline. Automated data pipelines are crucial because they eliminate manual data handling, which can be time-consuming and prone to errors. Automation allows for continuous data flow, ensuring that your AI models have access to the most up-to-date information. This is particularly important in fields like finance, healthcare, and e-commerce, where data changes rapidly and decisions need to be made in real time. Key components of data pipelines. When designing an automated data pipeline, there are several key components to consider. First, you need a source of data. This could be anything from databases and APIs to web scraping or IoT devices. Next, you'll want to implement data ingestion tools that can fetch and store this data efficiently. Once the data is ingested, it typically goes through a process of cleaning and pre-processing. This step is crucial because real-world data is often messy and may contain missing values, duplicates, or inconsistencies. Tools like Apache Airflow, Luigi, or even cloud-based solutions like AWS Glue can help automate these processes. After cleaning, the data often needs to be transformed to fit the requirements of your AI models. This could involve normalization, feature extraction, or encoding categorical variables. Finally, the processed data is stored in a format that can be easily accessed by your machine learning models, such as a data warehouse or a cloud storage solution. Challenges in data pipeline management. However, managing data pipelines is not without its challenges. One common issue is dealing with data quality. If the data fed into your models is inaccurate, your predictions will be as well. Implementing validation checks at different stages of your pipeline can help mitigate these risks. Another challenge is scaling. As your data volume grows, your pipeline needs to be able to handle increased loads without performance degradation. Using distributed computing frameworks like Apache Spark can help in managing large datasets efficiently. Finally, monitoring your data pipeline is essential. You want to be alerted to any failures or bottlenecks in real time to ensure a smooth workflow. Tools like Prometheus or Grafana can help with monitoring and alerting, ensuring that your pipeline remains robust and responsive. Model training and evaluation. Once your data pipeline is established and running smoothly, it's time to move on to model training and evaluation. This is where the real magic happens. You'll need to decide on the algorithms you want to use based on the nature of your data and the specific problem you are trying to solve. It's crucial to split your dataset into training, validation, and test sets. The training set is used to teach your model, the validation set helps in tuning hyperparameters, and the test set is reserved for evaluating the model's performance once it's fully trained. Frameworks like TensorFlow, PyTorch, or scikit-learn can assist you in building and training your models. Additionally, it's important to consider the computational resources available. Training complex models can require significant processing power, so utilizing cloud services or dedicated hardware may be necessary. Monitoring and maintaining models. After deploying your AI model, the work doesn't stop there. Monitoring model performance is just as important as the initial training phase. Over time, models can suffer from performance degradation due to changing data patterns, a phenomenon known as model drift. To tackle this, you should implement a monitoring system that tracks key performance indicators, KPIs, such as accuracy, precision, and recall. If your model's performance drops below a certain threshold, it may be time to retrain it with new data. Moreover, it's beneficial to set up automated retraining pipelines that can retrain your model at regular intervals or when new data becomes available. This ensures that your model remains relevant and keeps delivering accurate predictions. Integrating model deployment. Now that we have a solid foundation with our automated data pipelines and model training, we can discuss model deployment. Deployment is the process of making your trained model available for use in a production environment. This can take several forms, such as deploying to a web service, integrating into a mobile application, or making it available through an API. When deploying your model, consider how it will interact with your existing infrastructure. Containerization technologies like Docker can help encapsulate your model and its dependencies, making it easier to deploy across various environments. Additionally, orchestration tools like Kubernetes can manage containerized applications at scale. It's also important to plan for version control in your deployments. As you update your models or change your data processing algorithms, you'll want to ensure that you can roll back to a previous version if something goes wrong. Implementing a versioning system for both your models and data pipelines is essential for maintaining stability and reliability. Challenges in model deployment. Deploying models can be fraught with challenges. One significant issue is latency. If your model takes too long to respond, it may degrade user experience. Optimizing your model for inference speed is crucial. Techniques like model quantization or pruning can help reduce the size and complexity of your model, leading to faster response times. Another potential challenge is ensuring security. Exposing your model through APIs or web services opens up vulnerabilities if not managed properly. Implementing authentication and encryption for data communications can help safeguard your model and the data it processes. Lastly, ensure that you have a plan in place for maintaining and updating your deployed model. The process of monitoring, retraining, and redeploying should be automated as much as possible to minimize downtime and maximize efficiency. Conclusion. To wrap up, building a production-ready AI workflow that integrates automated data pipelines with model deployment is a multifaceted process. It involves careful planning and consideration at every stage, from data collection and pre-processing to model training, monitoring, and deployment. As we've discussed, the key components include establishing robust data pipelines, utilizing the right tools for model training and evaluation, and ensuring seamless deployment and monitoring. The challenges you'll face along the way are opportunities for growth and innovation. By embracing automation and staying vigilant about data quality and model performance, you can create an AI workflow that not only meets current needs but is also adaptable to future changes. Thank you for joining us today. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more content on AI and machine learning. If you have any questions or want to share your experiences building AI workflows, please leave a comment below. Until next time, keep building and innovating.